Okay, so we were recording, sharing our screen, I think we're all in good shape. Thank you guys for the tour outside. So I think it was pretty cool to watch all the equipment go through and be on the beach. So thank you, and it's always a treat to get some Nick Sport time. So hope you guys enjoyed Nick. So again, we're gonna have our day 2 demo folder. We're gonna pop it in our QCIT directory in MATLAB. So I pre-populated a couple things. So I made things look very similar to our old setup that we had yesterday. So we have collection data with our video, which I showed earlier. And then I also have, I have a text file with our GCPs that they are numbered, and they have X, Y, and Z, or northing, easting, and elevation, and NAVD. And then I also have intrinsics that we had calibrated earlier as well. So this, we had already gone through the Caltech Toolbox, and we went into it using format intrinsics to make it into a map file that was our same in our format. Now, I will say these are intrinsics. They are not the right intrinsics. These are intrinsics from a different ANAFI. Not because we were lazy, but I think it will be good to show what actually happens if you use different intrinsics for a different bird. So it can affect things. And we ran out of time. So we will start first with AO movie frames. So what we want to do here is we want to go in and get our user input, our loading, saving information. So where, first we want to point to where the movie lives. So a lot of times you can write it all out. When I get particularly in a hurry, I usually open it in Explorer. I do properties, security, and then I just copy it. Feel free to do whichever version you would like. You can, do it locally. You can do it the full path. It's up to you. So don't copy exactly this part because that will not match unless you named your computer Chonkosaurus. But it should work if you put it like this for a relative path. While you guys are entering that, and let me see, let me make it a little bit bigger. There we go. So what are we going to call this? We could call it UAS demo, so for right now, I think just to give it a little different name, we'll just call it CiRN, CiRN demo. Then we will enter the directory where the images will be saved. So I like to put mine in the collection data folder. Make a folder, and we can call this, we'll just call it CiRN see, I'm getting all my capitals and stuff messed up. CiRN demo. And then we are going to do, I do P1 Hertz, and I'll explain what that means later. So again, you can call it whatever you'd like, but I would call it this just in case you get lost in the future for the boot camp. So we want to put that path in here. So again, if you can type it all out. If you're lazy like me, you can go to properties, security, and just copy it. So we'll give everyone a second to get all this in, and then make sure we are all good. This should be the local directory. Ah. My keyboard stopped working. Okay, here we go. Okay, are we all there? Do we okay, no worries. And again, like I'm doing this on a lot of coffee and adrenaline. So like if you think I'm doing a mistake, let me know and we can talk through it.
I don't think you need the CiRN QCIT in that.
See, there you go, Jenna. Boom. Teamwork.
You're gonna get mad if you don't put it back up there.
I don't think so, but to be safe, let's do it. All right, how we're doing? Okay, I think we're gonna move on to the next part. So input, timing information, and frame rate. So the timing information, I wasn't there for the collect. It's always really good to be there when you're collecting to get this information. So I forgot. I don't know. So again, we can actually go into what we go into our folder. We kind of look at properties. If you click under details, so you can see the media. So some of them changed, but this one says, here we go, date created, date modified. So we have May 5th, which was Friday, at 11:27 a.m. And remember, this was on, it's going against my computer clock, which is actually in West Coast time right now. I don't know why. I just never fixed it. So it was actually at, let me do the math, +3, 2:27 p.m. So which in GMT, if you guys want to do GMT, is actually at 4. So that is 18:27. So again, writing things down, record keeping, clear of your timing is really helpful. So we will go to 2:23, 5, 18, 27. Now, even further wrinkle in this, that was when the video actually stopped recording. So if we want to do it when it started, we need to subtract 5 or 6 minutes from it. We're not going to do that precision today. So we're just kind of doing a generic one. But if you were doing it towards like an instrument or something like that, you probably would want to get that precise. So now we're going to do frame rate. So, typically to get CBATHY to do anything really useful, we get 2 hertz. To save time and to save space on everyone's computer, we're actually going to do one at every 10 seconds. So that's 0.1 hertz. And so that's why I did P1 hertz. So it did recognize 0.1 hertz. So let me try to, I feel like I need a signal when someone's done it, like anyway. All right. So there, you guys good? I did 0.1 to do every 10 seconds, just because it's going to make a lot of photos and take a lot of time. So just to speed things up, we're going to do every 10 seconds. So then we'll hit F5. So it's going through. Okay. I heard some dings. I heard some. So this one worked on this computer. Here we have our images. So you can see they're in epic time in milliseconds. You can open outside MATLAB, look at them. It's always a good idea to open them up, look at them, kind of pass through them just to see that things make sense. Maybe at 10 seconds it won't, but like if you're seeing that the wave is only moving like this much, like very, very small, your DT is probably wrong or something. So it's just always good to check. So just make sure things make sure it makes sense, what their waves are coming in, you know. It's a little harder at 10 seconds to see. And so did anyone have issues with making their images? All right, one down. We got this. Next we're going to do the GCP selection. So if you want to close this folder out, open GCPs. And so this is the function where we're actually going to go in and we're going to click and we're going to number them. And like I said, there's a few different ways to do this. One way, and I'm going to go in and just kind of show you some examples because I skipped over this part. Yep.
So did you skip A because you guys already did it?
We already did it. Sorry. Yes. So, I mean, once you do your intrinsic calibration for a sensor, as long as nothing changes, like you don't add a lens to it, you don't change the video frame rate, you can use that for flights on flights on flights. But yeah, so we had already done it, but that's why we had skipped A. And so I'm going to go to the arrow point. Well, first I'm going to click, it's kind of hard on this big resolution screen, but I do want to point out some things. So this is our image that we're looking at. And so just for kind of comparison, these targets out here, these are our big 4x4 targets Nick put out. These ones right here are the arrow points. So that's just like kind of just what you're looking at when it's helpful to put the arrow points on top of those. And so they're a little tough to see. So that's kind of an example, but you can see we have our targets from the pier, which are right here, which we've already surveyed, so we know those. And then we have these arrow points along here. And then, so let me pull out let me get the arrow point website up real quick and just kind of show you what that looks like. Yeah. So this was May 5th. So this is kind of our workspace that we have. And so even these, so they plot them out for you. It's super nice. However, let me go into the picture again. Come on. Got too many windows open. So here's where our map is, and this is really nice because it's overlaid on a satellite image, so we can use these points of reference to figure out where these guys are. However, you know, you kind of look at this picture and this picture, it's kind of hard to tell which ones are which, especially if one of them doesn't work. And so it actually, and I could even be, yeah, I think I could even be, so we look at them, I believe that this one corresponds to this one corresponds to this one, and this one corresponds to this one, and that one corresponds to that one. However, Without this satellite image, it's actually kind of like if you were just to plot this in space on a white background, like it could have easily been these. So that's why it's really good to try to keep record keeping and try to plot these ahead of time. And so the other thing that made this collect a little tricky is because we use two different sets of error points that we purchased, they load at different groups. So at first I just thought we were all in one group and I downloaded them and I was like, why do we only have 4? There's like 8 out here. And so again, it was kind of just making sure you keep track of everything. So here's the other collect of points we got. And so this one, because we didn't put the big targets, is even kind of harder to see. So this one is this one. So this one didn't collect. So when you're trying to line them up, we don't see it. But that was hard to know. At first, I thought it was this one. And so not knowing that, after going all the way through, I couldn't get my extrinsic solver to work at all. And that's a big issue that happens a lot. And then here are the 3 here. But so that was just kind of a little kind of explanation on the points. Another thing that also can happen is I got this image and I said, oh, these are the peer targets. I'll just use the same GCP targets we used in the demo yesterday. And I didn't realize that was in 2015. We had repainted and moved the targets since then. So my solution it wasn't working, and I couldn't figure out why. And then I realized they weren't the same targets. So hopefully we won't have that issue today. And so again, I like to load my text file, plot my GCPs with their number, and kind of print that out and have that to look at when I'm clicking. It's really hard to have all these screens open on this particular screen, so I just memorize them. So we'll go through that way, but that's what I typically like to do. So let's go in. So we're going to go into section 1. So let's name, what do we want to save it as? So we've been saving everything as CiRN demo. And again, a lot of this is going to be repetitive. It's going to be like, where is this file saved? Where is this file saved? And we did that so people can plug and play with different solutions, like use different GCPs, use different coordinate systems. If you make this operational, you can kind of bake this all in so you're not repeating it every time. So where is the directory where the map file will be saved? So let's put it in extrinsics, intrinsics folder. And let's make a folder called initial values. And so we will have show it 4 properties.
Brittany, I think you need to put the initial values folder.
Yep, see? There you go, guys. Teamwork. I was just testing you. And generally, when you make your text or CSV file, I like to try to make it easy myself and number them in like one direction. So like go north to north to south or south to north. That way you're just kind of like, okay, I need to move this way across my screen. Okay, so are we all good here? Okay, awesome. So now we're going to point to where our GCP image actually is. So for a UAS collect, we want to do our first frame. So we go into our CiRN demo. and then click on that one and put the, get the file path of that. It's mad at me because I opened a lot of windows. Come on. Oops.
Okay, well, I can start. Okay.
Where?
All right, you guys ready? Okay, cool. So now that's all we need to input. So we inputted where we want it saved. We inputted what image we're gonna pull. So now we can hit F5. And so did everyone get an image?
Which image did you?
The first one, just the first one in the folder.
Does it actually matter if it's the first one or not?
The way this is designed, yes. Because it's just designed to move forward in time. Like you could, if you building your own code, you could make it not be the first one. Okay, so we're gonna go ahead and start clicking. I think I have it from memory. We will find out. So the way I did it is I did the land ones first, going from south, yes, to north. And then I did the pier ones starting from in the pier going out. So we are going to start with number 1. So if you guys want to zoom, and then you can zoom in on this guy, the little tiny guy, hit enter.
Where was that?
I'll zoom out in a second. So hit 1. So we're going to call this one number 1. And so it's right here. If you mess up, don't worry, we can delete it and do it again. So I'll admit with this GCP placement, it's probably a little 12 is overkill. We were kind of just doing some practicing. So like, you know, maybe next time we would take a couple less from here and like put some more up in the dune to get that image corner. But you know, it's always you learn something every time. So the next one, if you remember, I said that other one we didn't load. So actually, I'm gonna go search for this too. So let's see, that one was no good. And then so we're going to, this is a point right here. So let me zoom out. So if you kind of see, there's this person, there's a point here, and there's a point right below it. So we're going to do that point below it. So that should be number 2. Actually, yes. Okay, did everybody get, oh, yeah.
There are a few right there, so it didn't work.
So the next, so yeah, so I know ahead of time because so from the arrow points, this one didn't load actually. This one right in the middle. This one right here.
No, you're where you're two.
Yep.
Down a little bit to the, yeah, right there, that looks like one.
It's not, it's dirt. Like it's like, but yeah, so that's why getting those big ones is actually really helpful. Or it's like some vegetation. But so now that we did 2, if you guys look right up, that one's going to be 3, the one right above it. We have one more small one, guys. Then we can go to the big ones. So. That was Nick's idea. He's like, I'm going to put some out without the big targets and see. Yep.
Gonna make this work for us.
Mm-hmm.
Right.
Every, like, you. And then you some collective.
That was right here.
Okay, so after 3, the other one is right. Let me go ahead and just do it. So after 3, 4 is a tiny one, and it's right at the corner of the ramp going off.
I see.
So I'm going to go ahead and click the rest and then zoom out so you guys can see them, because I think you'll be able to see where to click from there, and what to order that, name them.
Yeah.
But you can see that these big ones had the arrow points sitting on top of them, and it didn't really mess up how they look. They're still pretty. Oh, nuts. Did I mess this up? See, I think I already made a mistake. Let me double check. So don't follow what I'm doing right now.
That looks good.
Yeah. Okay. So number 5 that I just clicked is actually an arrow point that didn't work. So to get rid of it, we hit enter again, and then you do a right click, and now it's gone. So I meant to do that, guys. Yeah.
Ah.
Brittany, could you do that to number 1? Right click on number 1.
Mm-hmm.
Doesn't have to be the last.
No, it doesn't have to be the last one. So you can realize you made a mistake earlier or later.
If you right click on number 1, it doesn't show your numbers for the other ground.
No, they're just going to stay the numbers they are.
That would be
And some people like to, go ahead and click first and then go back to their coordinates and match it in their text file. Some people like to have the text file first. So it's kind of preference. And I forgot to mention, we want to click in the center where the white and the black meet that center point.
Oh, sorry.
And then I'll zoom in on these guys too, because these ones at the end of the pier are getting a little faded, so.
No, it's just.
Anything like.
Yeah.
And then once we find it too, and the two, we don't need to like all there.
You don't? Oh, okay, cool. Thanks, yeah. Gotcha.
You can have more control points in your file than you actually put on.
Yeah.
So you don't.
Yeah, you're right. I didn't know that. Yeah. Well, I'll be honest, the first time you're doing this, it's like, oh, this is fun and exciting. And then after like 4 of these, you're like over it.
Yeah. And then like.
Yeah.
But I mean, I'm enjoying teaching you guys. So, And this is, informal. So if you guys want to go use the bathroom, get water, take a break, like, you're free to. We are going to have lunch at 1. The public sandwiches are coming back. So hopefully we'll be done by then. May be working through it, but we'll see.
Brittany, so what level of versions did you like when you're using the air?
Error points. Yeah, that's kind of tough to, like, I don't put like 2 next to each other, assuming one's gonna break, but like, I try to just get enough as I can, like, to get areas of the image. But I would say usually, on average, 1 doesn't work. Like, if we have a group of 10, like, I bank on 1 not working. And like over time, we've kind of learned, like, we'll put a little question mark on the one that always acts up a little bit. I'll be honest, like, some people's phones and carrier plans just work better with it. And then also, like, some people, I think it works better too if you have a hotspot, like an actual dedicated like cell hotspot versus your phone. Like, you can buy like a. Yeah, so that was one big complaint, and I'll have to ask Nick. They may have been trying to remedy that. Like, I think, because it goes through your phone, which isn't like ideal because it's. Yeah.
Thing, but you have to be able to change the name of the network and the password, what the color is looking for, and then when it finds it, it starts dumping the data. You have to think where you are.
Yeah.
Like carry them back to.
You can go back if you want.
Oh yeah, you can go back to you can do them the next day, like, and like.
Drive them back, they'll slowly kind of upload.
Yeah.
And I know we've been saying, like, kind of emphasizing how they don't work, but like the fact is, like, we use them all the time. Like, we're still talking about them, so they are really useful and great. We have errors with the GPS sometimes too. So, does everyone have all the clicks? Are you feeling good about it? Okay. So I am going to, now that I'm going to hit enter one last time. So I have my crosshairs, and then I'm just going to click down here to end my collect. And so then it should list all your GCPs down here, and in your folder. In extrinsics initial values, we have our GCP UVD initial. So we have our initial UV D coordinates. D is just, again, emphasizing that we are in a distorted image.
So it just saved that GCP as ND. Oh no, it saved the.
It saved this one, sorry. Was everyone able to get that file? All right, 2 down. So the next one we're going to open is C, the single extrinsic solution. So we'll go to section 1. CiRN demo. So now we want to enter the directory where the IO, EO, which is intrinsics, extrinsics file will be saved. So this is where we want to save it. So again, we're going to save it in that initial folder directory. You can either go back to our old file and get it there, or you can pull it from Explorer again. So let's see, initial. Okay, we good here? I'm gonna scroll down a little bit. So now, section 2, we're gonna go find our intrinsics. So we're going to go into, we'll find that Anafi 4K file. Sorry, let me close some of these out.
Brittany, from there, if you just click that on the bar, there's enough.
Oh, which one? What one?
No, keep going, yeah.
Oh, okay.
Yeah.
If you just, if you click right here,
Mm-hmm.
doesn't that?
Oh, that too. You learned something new. And you're on the Macs too.
Well, I used to be on the Windows.
Oh wait, I didn't get the file though. Uh-oh. But that's okay.
Yeah.
It's still quicker.
Just different. Might not be fast. It's different. Yeah.
Okay. So again, sorry, that may have been a little, we want for this IO path variable, we want it pointing to that Anafi 4K mat file.
No arguments.
And Brittany, that is a crowd there.
The direct output from the Caltech, you go into A, format intrinsics, that will produce a map file, and that's what we're using. Ultimately, the Cal file, when you save it, it has like hundreds or dozens of variables and stuff, and we just take it and put it into one intrinsic variable. That's all we do. We don't do any math or change anything about it. We just literally just kind of streamline it. Okay, so are we pointing to we got section 2 done. All right, awesome. So section 3, we're actually going to point to our UVD, so GCP UVD path. So that is the file we just created by clicking. So where we put that is right here. So again, under initial values, GCP UVD, that's where we're going to want to get that path. Sorry, Chris, old habits die hard. I'm gonna, yeah.
Yeah. So one of these is.
And then the next one, well, this is when we're going to point to the CSV file. So this is your GCP XYZ path. So that is this folder right here, or this text file right here. So we'll put the path there.
Yeah.
And where's your text file?
Sorry, so the text file is in, let me close all these up and clean it up a little bit. It's in extrinsics, intrinsics, and then it's it's just in the extrinsics, intrinsics file folder.
Is it gonna be the CSV here or like?
Yeah, should be.
It's supposed to be a CSV?
Yeah. It does, I mean, you can use text files too. This particular one is just CSV.
And those are GPS location of the GCP,
Yes.
and they have to be formatted as the non-CSV.
So it's just, it could be a text file. It just has to be the GCP number, X, Y, and Z, by commas.
Yeah.
Okay, guys, were you able to get these two paths in? Are we feeling good about that? Nope. Okay. Meg, can you help Derek? Okay. All right, I'll give about 5 more minutes because I still hear a lot of chatter. So. Mm-hmm.
I just read.
Yeah, so I mean, it's honestly, so it can be. Sorry, I've been being a little cavalier with saying it. It can be a text file. It can be a CSV file. It can be anything. Is that a government computer? I'm gonna try to get one like that.
Yeah.
No. How did you get a computer? I've been trying to order a computer for like. It's been a while.
Well, this is Ty's old one.
Oh, that's how you got it. Okay.
I technically worked here for a month before I had a computer.
Nick Cohn worked here for a year before he had an email. So, okay. Yep.
Thank you.
Oh no, there's other people. I didn't mean to point you out. I was just, if you needed help, like there's other people. Okay. So I think we're gonna scroll down. So, okay, now we're at enter description of the GCP World Coordinate System for your own records. So we're using the same system because they've all been at the FRF, so we actually don't have to touch this one. Enter path of the image you would like your GCP reprojection checked against. So technically this could be any image you want to actually make sense and to assess accuracy. I usually like to use the same one that you used in your GCP selection in script B. So in script, what that was again was the first image in this guy, in this collection data CiRN demo P1 Hertz folder.
Yeah.
And then this next section is the GCPs we'd like to use for our solution. So these are the numbers that we clicked in. So we want to make sure our numbers are the same that we clicked, and they also match the text file. So we had 12. So let's go ahead and put in till 12. So this is going to use all of them.
Oh. Wait,
Oops, sorry. Did you guys do the ones on the pier? Okay, so you guys just go to 8.
Yeah, we'll see how it goes.
Yeah, that'll be good.
That's too bad. That's what we did.
I'm glad you guys asked because it would have been like, you would have been putting 12 in it and it would work. I don't know.
Well, they kind of figured, you know, it has no 12.
Okay, so I think we are done entering paths for this script. Sorry, there's a lot of paths. And then, so you guys good? Are we up to GCPUs? Are we feeling good about that? Okay, cool. So the next section is actually where we're going to spend probably more of our time. So this is the initial solution part where we're going to put in our initial guess of where we think the drone is, where it's looking at, or the orientation, and then our flags, whether it's known or not known. And then I think, yeah, so that's our last input section. So honestly, I say let's try to run it and see if our guess from before, from the other drone, would give us a good answer. It's probably not. So we can go see and just see what it does. So I would hit F5, and that way we can identify if there's any errors that have to do with the initial guess versus putting our paths in correctly or not. So, so it actually gave us a good guess, which is not what I thought it would. So, so that was odd, but we'll go through the parts. So did everyone get a plot that looks like this with the red and yellow dots? Okay. Did anyone not get it and need some help? Okay. Oh, no, you did get it.
My text scan's not working. Okay.
That may be a MATLAB version thing. I don't know. So you may be wondering, why isn't our points great? We're still not really aligned very well. You can see everything's kind of in the general same spot, but just a little off. Particularly you can kind of see at different points in the screen. And this is usually when you have bad intrinsics. Or intrinsics that are a little off. So like I said, this intrinsic file was actually from a different Anafi. And that's why it doesn't look amazing. We're just going to go forward because, it's still okay just for these purposes. But I did want to show you guys, like, this is a type of error you'll see if you have bad intrinsics. Now, if you have really bad intrinsics, you're going to get something crazy. But just something that's a little off is probably a refine your distortion model or something like that. So we can also go around and kind of play with some things. You, Crystal?
Is this the step that Athena, you were saying you take a photo to get
the first guess.
Yeah. So
would
she
be-
puts that right here.
Yeah, so then I say, okay, use the X, Y coordinates, and then it also gives you roll, pitch, and yaw.
Yep.
And I get mine from air data, so there's other options, like,
Well, air data gives you the same thing as
yeah, it just means using a state reader instead of X tools.
yeah. But first image gets you like really good data.
Sorry, Brittany.
No, you're good.
Anyway, you measure
Right.
your how bad is okay. So like you said the yellow and this.
Yeah.
Well,
I mean, just by your eyes, I would say targets that are really close to you and they're a little off, you're okay. But like targets that are super far away and they're a little off, like that's a much bigger error. And so it actually exports this out down here. It will reproject it and give you the error in space. So like some of them you can see have 20 centimeter error, but as we go down, some are 4 meters, 5. So you can kind of see it there. So it helps to have both. It helps to see that, and then it also helps to see it on the image. And so again, we can kind of play with our solution a little bit. Let's see if I can try to break it for us just so I can show you what kind of errors you'll get. So let's see if I do 90. Oh, it's still doing good. Okay, let's try to really break it.
90 nadir.
So this is for the azimuth. So I'm trying to mess with the azimuth. So nadir is 0. So yeah, so here all I did was change the initial guess of the azimuth. And now you can see it gave me something crazy. And so, that's why I always like to check what it actually says my extrinsics are. So if I look, so it says it's 120. So that would be, if we were looking south, just trying to make sense of things like that. And then you can see our errors are much bigger, 84 meters, 45 meters. So I will put that back at, I think our initial guess was 50. And so we'll go back there. And then, again, just to kind of show you guys the effects of having all your GCPs in a line. We can go up here and turn off, you can either just do the ones on the pier or just do the ones on the beach. So you just do 1 through 8. And so you can see now, because we focused our solution on just the ones on the beach, our error on the pier is worse because we weren't even considering those in our solution. And so I would imagine that even though these look really, really good, that probably the pitch is off or something's a little off. But you can, again, if we put them back in, we see our solution is better. And that error is just due to poor intrinsics. Yeah? There are some, and that's there are ways to iterate it, and that's actually what we've done with some of the horizon and what we've done with some of the shoreline analysis. And so, yeah, there is a way to iterate. Right now, the code for teaching purposes is just we iterate on our own and go back and forth. But that's a really good question. And so, so I think if everyone could go back and put, oh, sorry. Yeah, so I usually like to iterate with the first things I go to is usually the pitch and the azimuth usually are the troublemakers that cause it to break. Sometimes, now we have so many GCPs, sometimes we don't get a solution at all and we get a red error and it just says it can't find a solution. That's an issue as well. But I think the trickiest is when it actually does work and your GCPs are just out there. The trickiest is when you put it there and it solves it, and then you look at you double check your extrinsics and it says that you're upside down or something like that. So you always want to double check actually what is it telling you and does it make sense? Just so we can make sure we have a good file moving forward, if everybody adds 1 through 12 and then put your initial guess back to 50 here, and then hopefully if we just get a solution that looks like this. Because every time we were running this, we're saving over that old file. So just keep that in mind when you're playing. If you're oh, that's a good one, but I don't want to lose that, save a new file or something like that. And then when it's done, we should have under our initial values, we should have a file that says CiRN demo IOEO initial.